BrainQCNet is an app to detect artifacts on BrainT1-weighted scans. Concretely, it takes each volume and it returns a prediction of quality of this volume. So if it's 1, it means that the scan is actually damaged. If it's 0, it means that it's not damaged. So let's see how it works on CPU machines. In this short tutorial, we will focus on 2 steps, step 2 and step 4. Step 1 consists of installing Docker on your machine. You have the link here, it's very well explained. And step 3 consists of getting our best model, so it's stored here. And you will need to unzip the file you just downloaded from this link and to move this folder in the folder of your choice on your machine. So in step 2, we will pull the Docker image stored in the Neuroimaging repository on Docker Hub, and we will pull especially the BrainQCNet CPU image. So it's very important that you take this one because it works on CPU. Here we use the latest version, but you could use another version, specific one, and it's very recommended to make your work reproducible. After this step, we will just launch this command line. So a BIDS app has 2 levels, so participant level and group level. We will focus on just participant level in this tutorial because going from one level to another one is very straightforward. You just need to change the participant word in the command line here by the word group, basically. So we will just perform this for the demo. So this command docker run will create a container, a Docker container on your machine that will have all the environment necessary to run our BrainQCNet app. So we will first mount 3 volumes to this container. So the first one is corresponds to your BIDS data. So here you have a path to pass. It corresponds to the path where your BIDS data is stored on your machine. So you need to change probably the user by your username and BIDS data by the name of your folder. So it will mount this BIDS data in /BIDSDIR directory in the container. And we specify that we want to make it only in read-only because we want to avoid that the container actually write into this volume. The second volume we will mount is the output directory. So here again you should customize and enter the full path to this output directory on your machine. And it will be mounted in /outdir. So this time we won't specify read-only mode because we actually want that the container is able to write into this directory. And the third one is the saved models directory that you just created at the step 3. So here you should enter the full path to the saved models folder on your machine, and it will be mounted to saved models directory in the container. And here again we just mention in read-only mode because it's sufficient for our app. So after defining these 3 volumes, we will call the app BrainQCNet CPU. So here, if you pull the image like this, the name of the image on your machine will be this. So GarciaML / BrainQCNet CPU semicolon latest. So you should actually, instead of writing BrainQCNet CPU, you should write this full name here. Okay. So we will see. We will do that in the 2 machines after. After calling the app, by default, it runs the run.py script. And so this run.py script needs to have 3 parameters that are mandatory and exactly the same syntax as all BIDS apps actually. So first you mention the BIDS directory, second you mention the output directory, and third you mention the level of the BIDS app running. So here we want to run it at the participant level, and when you are at the group level you just change it by group. And after you can just pass a set of options that are defined in the run.py script, so feel free to have a look at it. Here we specify the model directory just to say, okay, my model is exactly stored here in the saved model folder. So this is useful because you could have many models actually stored in this folder, and we want to just to target to direct the app to the correct model. Okay, so let's see how it works on two different machines now. The first machine we will perform the experiment on is an Intel Core i7 processor with 16 gigabytes of memory. So first we will pull the image, the GaussianML slash BrainQCNet CPU image from Docker Hub. So we pull the latest version here, but feel free to use another one. Next, we show you here how to move the saved model.zip file. You just download it to another folder and to unzip it to get all the models somewhere on your machine. And next we will perform the docker run command. We change each path associated to each volume in the command line to put the correct ones. Okay, and if I run that, actually, yes, it says unable to find image, BrainQCNet CPU latest locally. So I just check quickly with Docker imageLess what name I should put for the image. So you see that it's the full name, GaussianML slash BrainQCNet CPU, colon latest. By default, if you don't put colon latest, it will just try to pull the latest version anyway. And this colon is very important if you want to run a specific version of your image. Okay, so it runs met2image first, and next it will process each slice generated by met2image to generate a local prediction, and next it will gather all the predictions of all the slices to generate a global prediction for the volume. You see that on this machine it takes some time, so in total it takes about 33 minutes to process one scan, so it's very long, but deep learning is not very appropriate to be run on CPU machines anyway. So the second machine we will use is a much powerful server with 64 gigabyte memory in his processor. So we first pull the correct image, so the GaussianML slash BrainQCNet CPU. We don't specify any tag here, so it will pull the latest version. So here you see several steps of pulling, and after pulling we just launch the docker run command that will just create the container on your machine with the correct environment, and that will launch the app within this container. So we adapt all the volumes by entering the correct paths to each folder, and yeah, and we also put the correct name for the image. So here it's GaussianML slash BrainQCNet CPU, and if you want to specify a version, so you add a colon and the version of the image you want to use. Okay, so after performing this, it will just launch the app. and it will just generate slices from volume, and next process each slice, and next generating global predictions and store everything in the output folder we mentioned above in the command line. And you see that in this machine it will be much faster and it will perform the whole process in about 10 minutes. So we just saw that depending on your machine, processing time can actually take longer or shorter. Be sure first that you have a sufficient amount of memory on your machine to run our app, and above all, enjoy using BrainQCNet.